Applications of integrals. Today we'll start with a new chapter titled Applications of Integrals. In this chapter, we shall study a specific application of integrals to find the area under simple curves, area between lines and arcs of circles, parabolas, and ellipse. Questions of a total of about 8 marks, one each of 3 marks and 5 marks will appear in your board examination. This is a very simple chapter, but you have to learn it with full concentration and practice it repeatedly. Area under simple curves. Area ALMB bounded by the curve y is equal to fx, comma, x-axis and the ordinates is given by is shown in the figure. The ordinates are x is equal to a and x is equal to b is given modulus of integral a to b of y of dx. You please see here this function fx y is equal to fx is a function al at the point L x is equal to a and at the point x is equal to at the point M x is equal to b. Hence, the total area under the curve y is equal to fx is given by the relations integral from a to b of y dx under modulus. Similarly, area ALMB bounded by the curve x is equal to fy. See here, x is equal to fy, y is equal to a is here at the bottom and y is equal to b is at the top. So this way or the other way also it can be written. X is equal to fy and the limit is from x is equal to a to x is equal to b and between L and M is shown in the diagram and it is given by the equation y is equal to b is mod of integral a to b of x of dy equals mod of integral a to b of f of y dy. So let us take up some word example in the form of questions and answers for 3 marks. There will be 3 marks question on this. Question number 1. Find the area of region bounded by the curves y square is equal to x and lines x is equal to 1 and x is equal to 4 and the x-axis. So please see the figure here. X and y coordinates are shown. O is the origin, x dash x is the x-axis and y dash y is the y-axis and 0 is here and y squared is equal to x is the parabola on the right hand side and x is equal to 1 is the vertical line here and x is equal to 4 is the line. So we are required to find, and this is the x-axis, we are required to find the area of the region bounded by y square is equal to x. Y square is equal to x is this curve and the lines, there are 2 lines, x is equal to 1 is here first line and x is equal to 4 is the second line. So the shaded portion we have to find the area of this region shaded. Equation of the curve rightward parabola. See, this parabola is a rightward, it is showing towards right side is given y square is equal to x and therefore y is equal to root x. This is the given equation and you have to draw the figure as shown in the figure. I used it earlier to explain it. So you draw the curves, that is you curve rightward parabola And therefore the required area, that is shaded area, here in this diagram the shaded area is equal to mod of mod of 1 to 4. X is equal to 1 is here and x is equal to 4 is here. These two lines of y of dx, and we have to substitute the value of y. Y is equal to root x as per the equation 1. So therefore the given equation becomes is equal to mod of integral 1 to 4 of root x dx. And we will root x is x to the power of half. So the x to the power of half, if we integrate, we know we have to put x to the power of half plus 1 from the knowledge of our integration. It becomes integral of x to the power of half dx is x to the power of 1 plus 1 half, and the limits are the lower limit is 1 and the upper limit is 4. Please don't get confused here. Upper limit is 4. Therefore, divided by 1 plus half, that is equal to 3 by 2. That is equal to 2 by 3. This is when it is goes to the numerator, it becomes 2 by 3. Modulus of 2 by 3. Now we have to substitute the upper limit first. Upper limit is x is 4. Upper limit is 4. 4 to the power of 3 by 2 minus the lower limit. The lower limit is 1 here. Therefore, it is minus 1 of 3 by 2. Simplifying, we get mod of 2 by 3 into 4 of 2. That is 4 of 2 minus 1. Because x to the power of 3 by 2 is given by x into half. That is 1 and a half. 3 by 2 is 1 and a half. So that becomes x to the power of 1 into x to the power of half. That is x is as it is into root x. So root x here is x is 4 and root x is square root of 4. That is square root of 4 is 2. That becomes, the answer is 2 by 3 into 8. 2 into 4 is 8 minus 1. That is equal to, it is 7. That is equal to 14 by 3 square units. That is the answer. Like we will take up the next question. Find the area of region bounded by y square is equal to 9x and x is equal to 2 and x is equal to 4. So two lines, x is equal to 2 is a line parallel to y axis and x is equal to 4 is a line at the point 4 parallel to y axis, and the x axis in the first quadrant. So in the question itself he has asked in the first quadrant. Equation of the curve, that is rightward parabola. This shape is called rightward parabola. That is y square is equal to 9x. Therefore, we have to draw the diagram rightward parabola and two lines. That is one vertical line at x is equal to 2 and another vertical line at x is equal to 4. Please draw the diagram and start the question. This diagram will not be given in the examination. Only questions will be asked and you have to draw the diagram. Because he has given the y square is equal to 9x is a rightward parabola. So therefore, y is equal to square root of 9x. Square root of 9x is 3 root x. Therefore, the required area, that is shaded area, that is between x is equal to 2 and x is equal to 4 is this region, and shaded area is this region. Therefore, is equal to mod of integral 2, that is x is equal to 2 to x to the power x is equal to 4 integral y dx. So we will substitute the value of y as 3 root x from equation 1. This is the equation 1 above. Therefore, it is mod of integral 2 to 4 3 of square root of x dx. Therefore, that becomes integral mod of 3 into integral x to the power of half dx. So square root of x is nothing but x to the power of half. Therefore, if you want to integrate, we have to add plus 1 and divide by n plus 1. So therefore, x to the power of 3 by 2 plus 3 by 2. Limits, upper limit is 4 and lower limit is 2. So we will substitute it. That is 3 will take outside. 3 and 3 in the numerator 3 and this 3 get cancelled and 2 remains. Therefore, it becomes 2 into 4. X value of x is 4. 4 into 3 by 2 minus the lower limit is 2 into 3 by 2. Therefore, x to the power of 3 by 2 can be written as x into x half. That is 3 by 2 is 1 and a half. So it can be written as 1 into x to the power of half. That is equal to x root x. So it will be, therefore we can write it as 4 root 4. Okay, x to the power of 3, 4 to the power of 3 by 2 can be written as 4 square root of 4 minus 2 square root of 2. So that becomes 2 into square root of 4 is 2. 2 into 4 is 8. So this term becomes 8 minus 2 root 2. That is, the answer is 16. 2 into 8 is 16 minus 2 into root 2. This 2 is outside here. Next question. Find the area of region bounded by x square is equal to 4y and y is equal to 2 and y is equal to 4. So y is equal to 2 is a line parallel to x-axis. Y is equal to 4 is also a line parallel to x-axis. And we have to find the region is between y-axis and the first quadrant. Okay, let us draw the diagram or graph. So equation of the given curve is upward parabola. X square is equal to 4y is an upward formula. You please note down and remember that x square is upward parabola, rightward parabola, leftward parabola. All those diagrams you please write down. Therefore, it is given x square is equal to 4y, or we can even, because is equal to, it is between x and y, we can write is equal to 4y can be written as y is equal to 2 is x square is equal to 4x, or x is equal to square root of 4x, that is equal to 2 of square root of y. Therefore, x is, we can take a write x as x is equal to square root of 2y, 2 into y. Equation 1. Therefore, the required shaded area is integral x dy. That is the equation dy. Here y is varying, dy. Integral 2 into 4. Integral 2 to 4 x dy. That is equal to integral 2 to 4 into 2 into square root of y. X is 2 root y. 2 root y we are substituting here into dy. Therefore, this equation becomes mod of 2 into integral 2 to 4 y to the power of half dy. Therefore, it becomes, if we simplify this, it becomes 4 by 3. This and this becomes 2, it gets inverted when it goes to numerator. 2 into 2 is 4 divided by 3 into, if we substitute the value of y as 4 by 3, 4 into root 3 by 2 upper limit, and minus the lower limit. Lower limit is 2. 2 into minus 2 to the power of 3 by 2. But 3 by 2 itself is x to the power of 3 by 2 is nothing but x root x. So we can put it as 4 root 4. So this can be written as 4 by 3 into 4 root 4 minus 2 root 2 as per this formula. Therefore, this can be written as 4 by 3 into 4 by 3 as it is. Square root of 4 is 2. 2 into 4 is 8. Minus 2 root 2 is as it is. So, taking LCM, we get the LCM is 3. The numerator becomes 8 into 4 is 32 minus 2 root 2. That is the square units is the answer. Next question. Question number 4. Find the area of region bounded by the curve y square is equal to 4x. Okay, y square is 4x and y-axis. This is the region is y-axis and line is y is equal to 3. So let us analyze. Y square equals 4x is a rightward parabola and y-axis is the line perpendicular to x-axis and line y is equal to 3 is parallel to x-axis. Let us solve this. The area bounded by the curve y square is equal to 4x. This is the area. Y square into 4x is a rightward parabola. And the line y3, y equals 3 is here. This is the horizontal line. So we have to find the area of the region bounded by this curve, the curve here. And this y is equal to 3 and the rightward of y-axis. This is y-axis. This is y is equal to 3 and the curve. So we have to find the area of this region. So the area OMA is equal to integral 0. This is 0. Okay, 0 to 3 of x dx, x dy. So we can substitute the value of x as y square by 4. So x, if you simplify this equation, x is equal to y square by 4. This equation. So y square by 4 into dy. It is integration with respect to y. So therefore, it becomes y cube by 3. That is y power rule. Y to the power of 2 plus 1 divided by 2 plus 1 is y cube plus divided by 3. 3 into 1 by 4 we have taken outside. So the limit is 0 to 3. Upper limit 3 and lower limit is 0. Therefore, it becomes 1 by 12. 1 by 4 into 3 is 1 by 12 into y to the y 3 to the power of 3. 3 cube it becomes. 3 cube is 27. So the lower limit is 0. If you put y equals 0 in the lower limit becomes 0. Therefore, only 1 by 12 into 27 remains. Therefore, it is simplifying. It goes 9 times. 27. 3 nines are 27. So it goes 9 times and 12 goes 3 times of 4. So the answer is 9 by 4 square units. We'll start next section by answering 5-mark questions. Question number 1. Find the area of the region bounded by ellipse. The given equation is x square by 16 plus y square by 9 equals solution. Equation of ellipse is copied as it is. That is x square by 16 plus y square by 9 equals 1. Let it be equation 1. Therefore, rearranging y square by 9 equals 1 minus first term is shifted to right hand side. 1 minus x square by 16. Therefore, y square is equal to cross multiplying 9 into open the bracket 16 taking LCM 16 minus x square by 16. Therefore, y is equal to taking the square root of the previous equation, y is equal to right hand side, square root of right hand side, that is 3 by 4 into square root of 16 minus the x square. Let it be equation 2. Intersection with y-axis is found, x-axis is found by putting y is equal to 0 in equation 1. In equation 1, that is, in equation 1, put y is equal to 0. Therefore, it will be x square by 16 is equal to 1, or x square is equal to 16, or x is equal to square root of 16. That is, x is equal to plus or minus 4. Next, we will find the intersection with y-axis. Intersection with y-axis is found by putting x is equal to 0. Therefore, in equation 1, put x is equal to 0. Therefore, x is equal to 0, or if you put x is equal to 0, y square is equal to 9, or y is equal to square root of 9, that is, y is equal to plus or minus 3. Therefore, we will plot the diagram of an ellipse. We know ellipse has got a principal axis, two principal axes, x-axis and y-axis, where the x coordinate is given by the a. The coordinate of A is point A is 4, 0. We have found here plus 4 and minus 4. So A will be 4 and 0. That is x is equal to 4 when y is equal to 0. Similarly, in minus side, negative side, x is minus 4 and 0. So we have got these 2 points. In the next case, we will put x is equal to 0. X is equal to 0 is y-axis. Therefore, if you put x is equal to 0, y is equal to plus 3. That is on the upper side, upward side. And in the downward, if you take the minus side, 0 minus 3. So we have got 4 points, A, minus A, B and minus B. When you join this, we will get an ellipse. We are required to find the area of the region bounded by the ellipse, as shown in the figure. Shaded area of the region is equal to total shaded area. So, instead of calculating for whole, if we consider only the total shaded area, we can calculate for only area, that is OAB, and multiply 4 times. So to find the total area of the region, we can calculate for one section in the first quadrant, that is OAB, and multiply it by 4. So it is given as area of the region is equal to total shaded area equals 4 into area of OAB. Therefore, that is equal to 4 times mod of integral 0 to 4. You see here, y is varying, x is varying between the x is 0 here, it is varying to 4. Integral 0 to 4. Therefore, I will repeat 4 times mod of integral 0 to 4 y dx. That is equal to 4 into mod of, we will substitute the value of y from equation 2. That is, y is equal to 3 by 4 into square root integral 0 to 4 as it is. Y is 16 minus x square dx. Therefore, 3 into mod of 0 to 4, 16 is 4 square minus x square into dx. This is the standard form of integration. So the relationship integral, the standard form is a square minus x square dx. Therefore, recalling our previous integration standard, integral square root of a square minus x square dx is given by equals x by 2 into square root of a square minus x square plus a square by 2 into sine inverse of x by a. This is the standard formula for integration of square root of a square minus x square dx. So we have put the values here. Therefore, that is equal to 3 into x by 2 into a square minus x square is a is 4. So 4 square minus x square plus 4 square, a square is 4 square divided by 2 into sine inverse of x by 4, where 0 to 4, the lower limit is 0 and upper limit is 4. Now we will put the limit values of the limit. Therefore, that is equal to 3 into x is 4 by 2, 4 by 2 into square root of 4 square minus 6 square plus 8. 4 square is 4, 4 square is 4 into 4. 16 by 2 is 8. Sine inverse of x is 4 by 4 is 1. Sine inverse of 1 minus this whole term becomes the low for lower limit. When x is 0, this becomes 0. 0 plus 8 times 8 times sine inverse 0, that is 0. Sine inverse of 0. We know sine inverse of 1 is pi by 2 and sine 0 is 0. Therefore, sine inverse of 0 is 0. So, this also becomes 0. The leftover terms are 3 into, this is 0, this is 8 times pi. Sine inverse of 1 is pi by 2, pi by 2. Therefore, that the answer is 12 pi units. So in this problem, you have to remember three formulas from your previous chapters. That is, equation of ellipse is x square by a square plus y square by b square is equal to 1. Okay, where a is the axis, principal axis along the x direction and b is the principal axis along the y direction. And the standard integral of square root of a square minus x square into dx is equal to x by 2 into square root of a square minus x square plus a square by 2 into sine inverse of x by a, and sine pi by 2. Sine 90 is 1 and sine 0 is 0. So we will take up the next. Find the area of region bounded by the ellipse. This is same as the previous problem. Here the values of a and b are changed. The given equation is x square by 4 plus y square by 9 equals 1. Therefore, equation of ellipse is written as it is. So we will find the value by rearranging y square, and y is equal to 3 by 4 into square root of 4 minus x square. That is, let it be equation 2. So we will find the intersection along y and x. So x will be equal to, when y is 0, x is equal to plus or minus 2. And when x is equal to 0, y is equal to plus or minus 3. So we have found x is equal to plus or minus 2 and y is equal to plus or minus 3 for the ellipse. So we will draw the ellipse. The ellipse is drawn here. The ordinates of A are 2 and 0 in the positive direction. When x is 2, y is 0, minus 2 and 0. And y is 0, minus 3 in the negative direction and 0 plus 3. So we will calculate the value using integration for the first quadrant, that is quadrant 1, and multiply it by 4. So this is into 4, we will do it as done in the previous problem. So that is 4 times area of OAB. O is here, AB. If we calculate 4 times, then we will get the we will get the answer for the question. So therefore, it is equal to 4 times integral 0 to 2. Limit you see here 0 to 2 along the x-axis is equal to 4 into mod of 3 by 2 into 2 square. That is, we are putting the value of y as 3 by 2 into square root of 4 minus x square. 4 is 2 square. Now we will get the value. So this 2 goes 2 times. So we get 2 into 3 is 6 into mod of integral 0 to 2 into 2 square minus x square into dx. That is equal to 6 into x by 2. X by 2 into square root of 2 square minus x square plus 2 square by 2 into sine inverse of x by 4. Therefore, that is 6 into 2 by 2. It gets upper limit if you put it, it gets cancelled. 2 square minus 4 plus 2 of 2 into sine inverse of 1 minus 0 minus 2 into sine inverse of 0. Therefore, that is equal to 6 into 0 plus 2 pi by 2 minus 0. That is equal to 6 pi unit. That is the answer. As in the previous case, you have to remember these three equations given in the text box below. We'll take up the next question. Question number 3. Find the area of the region in the first quadrant enclosed by axis and line x is equal to root 3y and the circle x square plus y square equals 4. So equation of circle is x square. So it is given x square plus y square is equal to 4 is a equation of the circle. We have written it as it is. So the equation of the line is equal to x is equal to, it is also given root 3 into y and therefore y is equal to 1 by root 3 x. Let it be equation 2. Now we know if y is equal to mx, we have learnt in the coordinate geometry where m is the slope and the value of m is 1 by root 3. The 1 by root 3, if you take tan, that is tan inverse, if you take it, tan 30 is 1 by root 3. Therefore, theta is equal to 30 degrees. So, the given line is inclined at 30 degrees. And the circle, it is the circle and first quadrant. So given terms are, it should be in first quadrant and equation of circle is x square plus y square is equal to 4. That is, the radius is 2 and the line is given by the relations x is equal to root 3y or y is equal to 1 by root 3x. That is, it is inclined at 30 degrees. So therefore, y is equal to 1 by root 3x represent the straight line of the origin. Therefore, we have drawn the circle. So this is the circle of radius 2. You see here, the coordinates of 2 are, the coordinates of the point B are 2, 0, where 2 is the radius of the circle and 0 is the, here along the x-axis, y is 0. So the next is the inclined line. The question given is inclined line at 30 degrees and it has got coordinates root 3 and 1. Origin is 0, 0. So you have to draw the circle, rough circle and represent it by this one graphically. The point of intersection of the line and circle in the first quadrant is, point of intersection is root 3 and 1. So if you put here x is root 3, root 3 in this equation. So root 3 gets cancelled and y will be equal to 1. See in this equation of the line, if you put x is equal to root 3, then you will get y is equal to 1. Area of the area OAB, if you take OAB is the required area. That is the shaded portion we are required to find out. So this is nothing but OAB OMA plus ABM, AMB or AMB. This is the two areas. So we have to calculate it separately. So area of this is OAM is a triangle. That is equal to half into OM into AM. Base is OM, height is AM into that is equal to area of OM half into OM is root 3. Coordinate is root 3 and AM is 1. Therefore, that is equal to root 3 by 2. So area of triangle is root 3 by 2. We have found here in this, let it be equation 3. So now area of, we have to find ABM. ABM is that this is curved portion is A, B and M. If you find, it should be in terms of Y. Y is varying between root 3 here to 2. That is root 3 to 2. B it is going. It is moving. It is varying from root 3 here at the point of M and 2 at the point of B. Therefore, area of ABM is equal to integral root 3 to 2 into Y. Value of Y is, we have found Y is 1 by root 3 into 4 minus x square. Therefore, x square, y is from this equation, you can calculate y is equal to 4 minus x square. 4 minus x square we have found here and we are substituting the value. This is the standard equation and its integral is given by x by 2 into square root of 4 minus x square plus 4 by 2 into sine inverse of x by 2, whose limits is root 3 to 2. Therefore, substituting the upper limit of 2, we get 2 by we get 2 into pi by 2 minus root 3 by 2 into square root of 4 by 3. 4 minus 3 minus, this goes 2 times, 2 into sine inverse of root 3 by 2. X value is the lower limit is root 3 by 2. Therefore, it becomes 2 goes times, it becomes 0 plus 2 cancels with 2. So we get pi minus root 3 by 2. This is root of 1 is 1 itself minus 2 into this sine inverse of root 3 by 2 is pi by 3. Therefore, we are substituting the value of pi by 3. So area of ABM is equal to, from this equation, pi minus root 3 by 2 minus 2 of pi by 3. Therefore, that is equal to pi by 3. So if you subtract pi 2 pi by 3 from pi, that is 2/3, you will get 1/3. So pi by 3 minus root 3 by 2 square unit. That is the answer. We will take the next question. So therefore, this is not complete. Let us complete. Required shaded area is OAB is equal to area of OAM plus area of AMB. Therefore, area of OAM is root 3 by 2 plus pi by 3 minus of root 3 by 2. So this root 3 by 2 and this root 3 by 2 get cancelled and the remainder is pi by 3. So pi by 3 is the answer, is the area, required area of this shaded portion, shaded region. So we'll take up the next question. Find the area of a smaller part of the circle. See here, this is the smaller part of the circle given by the equation x square plus y square is equal to a square, cut off by line x is equal to a divided by square root of 2. So equation of the circle we know x square plus y square is equal to a square. Therefore, rearranging y square is equal to a square minus x square. Therefore, y is equal to square root of a square minus x square. Let it be equation 2. So, therefore, x is equal to, now given line is x is equal to a by square root 2. This is nothing but a line parallel to y-axis and it is less than a. Because a by root 2 is greater than 1, hence it is always less than a. So it is less than a. So please see the figure. Here we have drawn a circle of radius a. So this is a circle of radius a. You can take any value. And this is the line a by root 3. So in the right hand side, we are required to find the area of A, B, M, C. So this whole area we are required to find. So that we can divide it and keep it to the confine ourselves to quadrant 1 so that we calculate the area of ABM, and because it is symmetrical about the x-axis we can multiply into 2. So therefore the required area is 2 into area of ABM, that is equal to 2 into limit. See, limit is a is x is equal to, here at the point of a, x is equal to a by root 2 and the upper limit is a. So we can represent it as integral a by square root 2 to a into y of dx. Y is varying, you see, y is varying this portion. The line BAC is varying from a by root 2 to a. So therefore it is the y dx. Now we will put the value of y from the equation number 2. Therefore y is equal to a square minus x square into dx. We have substituted in the previous equation, and now this is the standard equation and we have to use sine inverse formula to get the answer, integral of square root of a square minus x square. That is, it is given by x by 2 into square root of a square minus x square plus a square by 2 into sine inverse of x by a is the standard formula, and we will put the lower limit and upper limit. Lower limit is a by root 2 and upper limit is a, as explained in the previous slides. Therefore, if you put the upper limit, upper values here, which is shown in the blue color for easy identification, we get x is equal to a by 2 into square root of a square minus x. X is a minus a square plus a square by 2. This a square by 2 for upper value. Sine inverse of x is a. A by a is 1 here. So now after substituting minus, this is the upper limit, and lower limit we will substitute now minus x is a by root 2. So that is x is a by 2 root 2. It becomes a by 2 root 2 into square root of a square minus x square is minus a lower value is a square by 2. Square root of square root of 2 is 2 into sine inverse x is a by root 2 into a root 2 we have substituted. Let us simplify further. That is equal to 2 into a square minus a square is 0. 2 into 0. This becomes 0. A square sine inverse of 1 is pi by 2. Pi by 2, a square by 2 into pi by 2 minus 2 root 2, a by 2 root 2 into a square minus a square by 2. This a square minus a square by 2 is a square by 2 plus it becomes inverse. This minus, if when it goes inside, it becomes minus a square by 2 sine inverse of a gets cancelled and becomes 1 over root 2. That is equal to 2 into pi a square by 4 minus square root of a square is a into a is a square, to root 2 into root 2, 2 root 2 into root 2 minus simplifying a square by 2 into pi by 4. Sine inverse of 1 by root 2 is pi by 4. Therefore, that is equal to 2 into pi into a square by 4 minus pi a square, this term, pi a square by 8 minus a square by 2 into 2, that is 4. So that we get 2a square into pi by 4 minus pi by 8. A square we have taken common, pi by 4 minus pi by 8 into 1 by 4. Therefore, that is equal to 2a square into pi minus 2 by 8. So the answer is a square by 4 into pi minus 2 of square units. So we will take up the next question. Question number 8. The area between x is equal to y square and x is equal to 4 is divided into two equal parts by the line x is equal to a. Find the value of a. So we are required to find the value of a. Equation of the curve. Write what parabola is. We have to write the equation. Given equation, we know x is equal to y square. Write what parabola is. X is equal to y square, or rearranging y square is equal to x or y is equal to root of x. Let it be equation 2. The area bounded by parabola 1 and vertical line x is equal to 4 is divided into two equal parts by vertical line x is equal to a. So this is a rightward parabola. X is equal to a is this line, and x is equal to 4 is this line. This is x is equal to 4. That is, from 0 you measure 4 and draw a line. And intersection of, we have to find intersection of x and y, we can find out here by substituting the values of 4. Here, if you put x is equal to 4, you will get y square is equal to 4 or y is equal to 2. So here it will be y is equal to 2. So area, the required area is OA OAMB. OAMB is equal to area. It is dividing equally. So the area is MAMBDNC. So because this line x is equal to a is dividing this rightward parabola into two parts, so area, the left side area of this line AB is equal to the right hand side area. Hence, therefore, we can put the equation as 2 into, because it is symmetrical about the x-axis, we can write it as 2 into integral 0 to a y into dx mod, that is equal to 2 into mod of a to 4. See, a is the limit, lower limit here for this region, right hand side region, lower limit is a and upper limit is x is equal to 4. So we have put the limit as y into dx. Therefore, dividing by 2 and putting y is equal to y is equal to root of x. Y is equal to root of x from equation 2. That is equal to x to the power of half. Therefore, we can put it is equal to y is equal to x to the power of half into dx. That is integral, that is right hand side is integral a to 4 into x to the power of half into dx. So the left side, the variation is this is 0. The left part is 0 to a and right side part is a to x, a to 4. That is what we have substituted here. Therefore, that is integrating x to the power integral x to the power of half using power rule is x to the power of half plus 1 divided by half plus 1. That is x to the power of 3 by 2 divided by 3 by 2. And it is 0 to a. The limit on the left hand side is 0 to a. The limit on the right hand side is a to 4. Therefore, it is x to the power of 3 by 2, a to the power a to 4 divided by 3 by 2. 3 by 2, 3 by 2. That becomes 2 by 3 on both sides into a to the power of 3 by 2 minus 0 equals 2 by 3 into 4 to the power of 3 by 2 minus lower limit a to the power of 3 by 2. Therefore, rearranging, we get, taking in terms of the left side is a to the power 2 by 3, 2 by 3 get cancelled. So, a to the power of 3 by 2 is equal to this 4. 4 into 3 by 2 is 4 root 4 minus a to the power of 3 by 2. Therefore, when this a goes to the left side, a to the power of 3 by 2 is there, and this goes to the left side, it becomes 2 times a to the power of 3 by 2. That is equal to 4, square root of 4 is 2. 2 into 4 is 8. We get a to the a is equal to 4, this goes 2 divided 8 divided by 2 is 4. That into inverse of 2 by 3. That is the value of a. So we have found the required value. Next question. Find the area of a region bounded by the parabola y is equal to x square and y is equal to mod x. So we know y is equal to x square is a parabola, upward parabola. Let us solve it. The area is bounded by parabola y is equal to x square and mod x. Y is equal to mod x means x can be x plus x or minus x. Therefore, mod of y is equal to mod x is equal to x in the positive direction. That is x greater than or equal to 0. Y is equal to minus x if x is less than or equal to 0. Therefore, rearranging, we get x square minus putting the value of x minus x equals 0, or x into taking x common, x into x minus 1 equals 0, or x is equal to 0 or x minus 1 equal to 0. That means x is equal to plus 1. Therefore, the value can be x is equal to 0 or x is equal to 1. So the points of reference will be intersection points can be 1 1. That is when x is equal to 1, y is equal to 1 for point A, and when x is equal to minus 1 for point B, y is equal to 1. These points are marked in the graph. This is y is equal to x square is a parabola, inverted parabola, both on the quadrant 1 and the first quadrant and the second quadrant. This is the parabolic equation. This represents y is equal to x square. Then there is a linear equation, y is equal to mod of x. So mod of x is a line here. A line y is equal to minus x is this side, minus x is this side, and plus x is this side. So this is the equation of line is represented by this flower bracket. So the given area is symmetrical about the y-axis. As seen from the graph, we see that the given area is symmetrical about y-axis. Therefore, area OACO, that is O, A, C is here, CO equals area OB, D is here, DO. So the point of intersection of parabola is y is equal to x square and line y is equal to x is 1, 1. We have found here x is equal to 1, y is equal to 1 here. Therefore, area of OACO is equal to, see this OA. Now we will calculate only the area in the right hand quadrant and multiply it multiply it into 2. So draw AM perpendicular. So now we have to find the area of this OAM triangle and subtract the area OCA. If you subtract the area, we will get the shaded portion, this shaded region, area of the shaded region. Let us do it. Therefore, area OAM is equal to half base into height, where because of this coordinate 1, 1, OM is equal to 1 and AM is equal to 1. Therefore, area of triangle OAM is half, 1 by 2. That is equal to area of OM ACO is equal to, now we have to find the area of OSCMO, where the y varies between, y dx varies between 0 to 1. So 0 to 1. It varies for this region. This is curve. Therefore, substituting the value of y, it is y is equal to x square is the parabola, equation of parabola, and we have put the value of y as x square. That becomes integrating, we get x cube by 3 and limit is 0 to 1. That is equal to x cube. If you put upper limit, it is 1 by 3. Therefore, the region is 0 is, it gets cancelled. Therefore, it is 1 by 3. Therefore, area of OACO is equal to, from the previous this line, OACO is equal to area OAM. OAM is the triangle minus area OAM. Minus area OCAM. Here, the C we have to add. Therefore, that is equal to area of triangle is half and this lower area is 1 by 3. That is equal to 1 by 6. Therefore, the required area is twice of that. So, 2 into 1 by 6. That is equal to 1 by 3 square units. We will take up the next problem. Find the area bounded by the curve x square is equal to 4y and so x square is equal to 4y is an a parabola inverted upwards, and the equation of the line is x is equal to 4y minus 2. Therefore, the area bounded by the curve x square is equal to 4y, and the line x is equal to 4y minus 2 is represented by the shaded area ODBCO. See here, please see the diagram. The required area is ODBCO. This is the shaded area. Let C and D be the point of intersection between the straight line and the parabola. So, you know the equation of parabola is x square is equal to 4y given here, and the equation of straight line is given here, written here, x is equal to 4y minus 2. In the examination, they may not give the diagram, but you have to calculate and write it. Therefore, we will copy down the two given equation, that is the equation of straight line x is equal to 4y minus 2, and the equation of parabola as x square is equal to 4y. So first, to find the intersection between the straight line and the parabola, we will solve these two equations. So it is solved, the solution is given here, x square is equal to 4y, and x minus 4y rearranging is equal to minus 2. So that is the equation 2. Solving this, we get the quadratic equation x square minus 2x plus x minus 2 rearranging, fact that is factorizing, equal to 0, or x is equal to 2 or x is equal to minus 1, which you know thoroughly from the knowledge of your previous classes. So using these equations, these relations, we will solve, we will try to find out the point of intersection C and D. So in this straight line equation, we will put x is equal to 0. When we put x is equal to 0, 4y is equal to 2, or y is equal to 2 by 4, that is 1.5. So this is 1 point, 0 and half is the 1 point. The next point is to find the second point, we put the value of y as 0. Therefore, x, if you put y is equal to 0, this equation becomes x is equal to minus 2. So that is written as 0 and minus 2. So we have got 2 points of straight line. The next is we will find the point on parabola. So here we will use the value of x as calculated in the previous quadratic equation. That is x is equal to 2 or x is equal to minus 1. When we take x is equal to 2, this equation becomes 2 into 2, 4. 4 is equal to 4y, or y is equal to 1. So when x is equal to 2, y is 1. Similarly, we will substitute the value of x as minus 1, which we calculated in this text box, is equal to minus 1. X is equal to minus 1. Minus 1 into minus 1, minus 1 square is plus 1. So therefore, y will be equal to 1 by 4. These points we will mark on the graph. The first point is A minus 2, 0. This is point A, minus 2, 0. So minus 2 is the negative point on the left hand side of the x-axis. Minus 2, 0 is marked here. That is point A. And similarly, point B is 0 and minus 2. That is B. Point B is 0 and half. So that 0 and half is written here. B is 0 and half, it is written here. Then in coming to this second, the parabolic equation, the point in parabola and all that. So C is minus 1 and y is 1 by 4. Minus 1 is here, and 1 by 4 is here. That we have written here. Minus 1 and 1 by 4, that is C, and point D is x is 2 and y is 1. So x is 2 and y is 1 written here. So we have noted down all the points of a straight line and a parabola, that is A, B, C, D. So draw CM perpendicular to CM and DN perpendicular to x-axis, that is perpendicular to x dash x. To get a trapezium CMONDC, this is the trapezium. So area CMOEDN, that is the area between the parabola and x-axis, is given by the relations integral mod of integral -1 to 2 y dx. That is the equation of this, the other area outside the shaded portion. That is y dx. That is, it is varying from -1 to 2. See, the limit at m is -1. Here it is shown here -1 to 2. Therefore, -1 to 2 of the equation of parabola is x square by 4. See here, y is x square by 4 from this equation, parabolic equation, x square by 4 dx. So integrating x square, we get x cube by 3. X cube by 3 into this 4 is x cube by 12. And the limits for this relation is -1 to 2 as shown earlier. That is -1 to 2. And that becomes 1 by 12 into 2 cube. Putting the upper value, the upper limit, 2 cube minus the lower limit, minus of -1 whole cube within the mod sign, modular sign. That becomes 1 by 12 into 2 cube is 8, minus of -1 it becomes. So the value is 9 by 12 or 3 by 4 square units. That is the region CMOEDN. This region outside the shaded portion is 3 by 4 square units. Now we will calculate the area CMDN between line 2, that is the line, equation line, and the x-axis, the whole trapezium. This is a trapezium. So we are taking C, M, N, and D. This whole trapezium is given by the relation, that is the again integral -1 to 2 y dx, and the equation is, the straight line equation is x plus 2 divided by 4. That is simplifying this equation, x plus 2 divided by 4 into dx. That is equal to modulus of, take 1 by 4 outside, you will get integral -1 to 2 x plus 2 dx. Therefore, this becomes, after integration, 1 by 4 you please take out outside, 1 by 4 mod of integral of x is x square by 2 plus integral of 2 dx is 2x, and the limit is -1 to 2 as shown in the diagram. That is becomes is equal to 1 by 4, putting the upper value first. So x square, in place of x we put 2. That becomes 2 square divided by 2 plus 2 into 2, 4. So minus, now we put the next step, we put the lower value. So minus of x square, -1 whole square is 1 divided by 2 minus 1 minus 2. That becomes 1 by 4. 4 by 2 is 2 plus 4 minus half plus 2. Simplifying, we get 15 by 8 units. So we have got two values. One is the whole trapezium and the area outside the shaded portion. If we subtract the outside area from the trapezium, we get the required answer. Therefore, the required shaded area is equal to area of trapezium CMND minus area CMOEDN. That is equal to, we have got 15, the whole area is 15 by 8 units from equation 4 minus 3 by 4. So that becomes, take 8 as LCM, that becomes 15 minus 6, that is equal to 9 by 8 square units. That is the answer. So you have to remember carry the step by step how to go about this problem. Next problem. Find the area of a region bounded by the curve y square is equal to 4x and the line x is equal to 3. So this is again once again the equation of a parabola. Y square is equal to 4x, which is inverted rightwards, and the line x is equal to 3. So this is shown in the figure. Y squared is 4x is a parabola, okay, touching the origin O, and x is equal to 3 is a vertical line. So we have to find the area between O and the line AB. AB intersecting with the parabola. Let us start. So y square is equal to 4x. This is a parabola in quadrant 1. So in quadrant 1, if you calculate the area in quadrant 1, that is OAMO, and multiply into 2, we will get the required answer. So we will confine to the area in the first quadrant. Therefore, the given equation y square is equal to 4x becomes y is equal to, taking the square root, y is equal to 4x, or x 2 into square root of 4 is 2 into x to the power of half. Let it be equation 2. So required shaded area is OAMB, and that becomes twice the area of OAM as explained earlier. So area of OAM is 2 into mod of integral 0 to 3. See here it is bounded by 0 here and 3 is here. So lower limit is 0, upper limit is 3 into y. Equation of y is y dx. That will be substituted. We will substitute the value of y as 2 into mod of 0 into 3, 2 into x to the power of half dx. That is equal to, taking integral, we get 4. 2 into 2 is 4 outside, mod of x to the power of half plus 1. That is, you know the power rule, x to the power of half plus 1 divided by half plus 1. Half plus 1 is 3 by 2, 1 and a half, into limits as it usual 0 to 3. The limits of this problem are 0 to 3. That becomes 4 into, we take 2 by 3 outside. So it becomes 2 by 3. 2 into 4 divided by 3 into upper limit is 3. So therefore 3 into 3 to the power of 3 by 2 and minus the lower limit is 0. So we put lower limit x as 0. So it becomes 0. Therefore, simplifying, we get 2 into 4, 8 divided by 3 into 3 root cube root of 3, square root of 3. That becomes 8 into this 3 and 3 gets cancelled. 8 into square root of 3 square units is the answer. This is a very simple problem. You practice it. Mostly you will get this question in your examination. Next question. Using integration, find the area of region bounded by triangle whose vertices are -1, 0, 1, 3 and 3, 2. So a triangle is given and we are required to find the area of the triangle. Here the vertices are given in terms of their coordinates. See, the points are -1, 0. So A is point A in the diagram. It is shown in the diagram. A is -1, 0. B is 1 and 3 and C is 3 and 2. It is shown in the diagram. So since coordinates are given, you are not required to calculate intersection and other cumbersome calculation. It is a very simple. What is solution? Vertices of triangle are A minus 1 comma 0, B 1 comma 3 and C 3 comma 2. Therefore, equation of line, as we know, is given by y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. This is the equation of the line given by respective coordinates, which we know from our knowledge of coordinate geometry. Therefore, at x is equal to, he has given y is equal to 0, y1 is equal to 0. So if you put y1 0 and y2 3 here between for the line AB, see, A is minus 1 0, B is 1 3. So we will put the values of x and y. So y minus 0, y minus 0, here it is 0 equals 3 minus 0, that is y2 minus y1 is 0 divided by x2. x2 is 1 minus of minus 1 into x minus minus of minus 1. See, x is minus 1 here. So simplifying, y is equal to, we get 3 by 2. That is y equals 3 divided by minus into minus is plus 1 is 2. 3 by 2 into x plus 1. So therefore, area of triangle ABL is bounded by the area by this line AB and x-axis. Therefore, it is integral, mod of integral minus 1 to plus 1, that is A to B. This triangle, we have to find the area of two triangles, that is ABL and BLC. So first we will find out the area of triangle ABL, that is mod of minus 1 to 1 y dx, that is equal to mod of minus 1 to 1 into 3 by 2. This is the relation we will substitute for y as 3 by 2 into x plus 1 into dx. So we will integrate this. So we will simplify and integrate. So 3 by 2 outside mod of minus 1 to 1 of x plus 1 into dx. That becomes 3 by 2 into mod of x integral x dx is x square by 2 plus integral 1 dx is x. Limit is minus 1 to 1. So modulus, that is equal to 3 by 2 into 1 by 2 plus 1 minus of the lower limit, minus of 1 by 2 minus 1. Therefore, it becomes 3 by 2 into, this is 1 plus half is 3 by 2. Half minus 1 is minus half. Minus half into minus is plus half. Therefore, it is 3 by 2 plus half. That is equal to, it becomes 3 by 2 plus half is 4 by 2. That is 4 by 2 is 2. 2 into 2 gets cancelled and the answer is 3. So we have found the area of triangle ABL. Next we will calculate the area of triangle BC. Here BCL. The line BC is given by same way. The BC we will get y minus 0 is y is y minus 3. Y minus 3 equals 2 minus 3 divided by 3 minus 1. That is this equation. Y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. So here the value of y1 is 3 and y2 is 2. Therefore, the equation becomes y minus 3 is equal to 2 minus 3 divided by 3 minus 1 into x minus 1. That is simplifying. We get minus of, this is minus 1. 2 minus 3 is minus 1 divided by 2 minus 1 by 2 into x minus 1. So we have found the equation of the line BC. Therefore, that becomes 7 minus x by 2. Therefore, area of trapezium BLMC. First, we will find out the area of trapezium. BLMC is equal to area bounded by the line BC and x-axis. Therefore, that is equal to integral mod of integral 1 to 3. See, this is varying. L is at the value of x equals 1 at L, and x is equal to 2 at point M. Therefore, the limit is 1 to 3. That is x equals 1 to x equals 3. That is equal to integral 1 to 3 of 7 minus x. We will substitute the value of y as 7 minus x divided by 2 into dx. Therefore, integrating, we get integral of 7 dx is equal to 7x minus 7x dx is minus x dx is x square by 2. So x square by 2 is written here. That is, limit is 1 to 3. That is equal to half. We have already taken outside into, if you put the upper limit as x equals 3, 7 into 3 is 21 minus 3 into 3 is 9 by 2. Okay, then again minus of the lower limit, minus into 7 into 1 is 7, the lower limit, and again minus of half. Half means x into x square, that is 1 square is 1 only, minus half. Again simplifying, we get the area of trapezium BLMC is 5. Now we will find the equation of line AC to find the area of the trapezium, y minus 0. So that is here LC equation AC. This is equation AC is y minus 0 is equal to 2 minus 0 divided by 3 minus of minus 1 into x minus of minus 1. Therefore, that becomes y is equal to 2 by 4. This is 2 by 4. That is minus into minus is 1. 2 by 4 denominator into x plus 1. Simplifying, we get it as 1 by 2 into x plus 1. Therefore, area of triangle ACM. Area of triangle ACM is bounded by AC and x-axis is given by integration in mod of integral 1 to 3 y into dx mod equals mod of integral minus 1 to 3 here. The whole triangle. You have to take the triangle ACM. Okay. So ACM you get minus 1 to 3 1 by 2 into the equation of this line into x plus 1 into dx. What that is equal to, when we take 1 by 2, this 1 by 2 outside, we get 1 by 2 into x square divided by dx, x square by divided by 2. That is integral of x into dx is x square by 2. Integral of 1 dx is x. So limits minus 1 into 3. Therefore, that becomes 1 by 2 outside. Putting the upper limit, that is x is equal to 3 in this equation, we get 3 into 3 is 9 by 2 plus x is equal to 3 is plus 3 minus 1 by 2 minus 1 by 2 minus of minus 1 is plus 1. Therefore, plus 1. That simplifying, we get that area as 4 square units. Therefore, the area of triangle ABC is equal to area of triangle ABL plus area of trapezium BLMC minus area of triangle ACM. Okay, first triangle ABL we are calculating. First area of triangle, then area of trapezium, and subtracting the area of triangle ACM. So all these values we have got in the previous equation. That is equal to 3. Area of ABL is 3 from this equation. And then area of trapezium is 5. This is 5 minus this is 4. That is equal to 4 square unit. That is the answer. Next question. Using integration, find the area of triangular region whose sides have the equations y is equal to 2x plus 1, comma, y is equal to 3x plus 1 and x is equal to 4. So, three equations are given which represent line 1, line 2 and line 3. They join in such a way to form a triangle. Let us solve it. And we are required to find the area of the region, triangular region. So the equations of the sides of a triangle are given by, as you know, it is given, and y is equal to 3x plus 1 and x is equal to 4. X is equal to 4 is a line parallel to y because here the value of y is 0. So if we put the value of 4 in this equation, in these two equations, we will get 2 points. So first let us find out what is the value of y when x is equal to 0. Therefore, put x is equal to 0 in equation 1. We get, if you put 0, y is equal to 1. So, when x is equal to 0, y is equal to 1. So, let it be point A. A is 0, 1. In the next step, we will put x is equal to 4 because x is equal to 4 is given in equation 3. So, therefore, we will put x is equal to 4 in both equation 1 and equation 2. First, we will put in equation 1. If we put x is equal to 4 in equation 1, we get y is equal to 2 into 4 plus 1. That is equal to 9. And therefore, when x is equal to 4, y is equal to 9. So, therefore, point B is 4 and 9. The next point is put x is equal to 4 in equation 2. That is y is equal to 3x plus 1. So, therefore, y becomes y equals 3 into 4 plus 1. Therefore, y is equal to 13. That is, when x is equal to 4 in equation 2, y is equal to 13. So, the point C is 4, 13. Now, let us plot all these in the diagram. So, therefore, this is a graph sheet. This is x-axis and y-axis. Perpendicular to x-axis is y-axis. When x is equal to 0, x is 0 here. Therefore, A is 0, 1. And point B is when x is equal to 4, y is 9. So, x is equal to 4 is this line. That is parallel to y. This is x is equal to 4. So, B is 4, 9. So, the point B is plotted 4, 9. Similarly, the third case, when x is equal to 4, y is 13. That is point C in this equation. And this is plotted in the graph as C within brackets 4, 13. That is x is 4, y is 13. All these three points A, B, C are joined. Now we are required to find the area of triangle A, B, C. Please note here A is not in origin, but the point A is 0 and 1. X is 0, but Y is 1. So it is slightly lifted up. Let us point this CL. CL is X is equal to line X is equal to 4 and it is joined meets X axis at the point L. So the equations are represented here. Y is equal to 2x plus 1. That is the line 1. Y is equal to 3x plus 1, line 2. And x is equal to 4 is this line, that is BC. Let us find out. So therefore, the area of triangle ACB is given by the area, total area O, L, C, A, O. This whole area, that is OL, BCAO minus, we have to subtract the area OLBAO. So if we subtract the outside the shaded portion, we get the area, the required area. We will calculate it. So the first is, we take 3x plus 1. So it is OLCAO is integral 0 to 4 3x plus 1. That is the equation of this line into dx minus integral 0 to 4. The limit is same for both the integrals. 2x plus 1. This is the outside the shaded portion. 2x plus 1 dx. Therefore, integrating, we get 3x is, integral 3x is 3 into x square by 2 plus integral 1 dx is x 0 to 4 minus 2x dx is 2x square by 2 plus x dx. That is limit 0 to 4. Therefore, we get 3x square is upper limit is x square is 4 into 4 is 16, 48 by 2 is 24 plus 4, x is 4 here, 24 plus 4 and x is 0 in the lower limit. So the minus term will be 0 in the first square bracket and then minus. This is the second area is 2x square. 2x square is, if we put the upper limit, we will get 16. X square is 4 into 4, 16 plus 4. That is equal to 8 square units. Next question. Find the smaller area enclosed by circle x square plus y square is equal to 4 and the line x plus 2 is equal to 2. So please note here a circle is given whose equation is given as x square plus y square is equal to 4. That is, the value of a in the standard form is a square is 4 or a is 2. And the equation of line is given is x plus y equals 2. Therefore, we have to, for solving this problem, when circle is given, we have to note the equation of circle. First point, please see here at the right hand side bottom. And we have to know the standard form of integration of the standard form is under integral square root of a square minus x square dx. That is given as integral square root of a square minus x square dx is, you have to remember from the previous chapter, x by 2 into square root of a square minus x square plus a square by 2 sine inverse of x by a. This formula, standard integration formula, you have to remember. You are also required to remember some other thing, the standard value of sine. Sine values or sine inverse values of standard angles. Okay, let us solve. The area enclosed by circle x square plus y square is equal to 4 and x plus y2 is represented by the shaded area in the graph. So this is the area of a circle whose radius is 2. This is marked here, you see, this is origin, O is the origin, R is the radius, or A is the radius equal to 2. So y is also equal to 2, x is equal to 2. and the equation is x plus y is equal to 2. X plus y is equal to 2 is this line. So this meets at the point A is 2 comma 0 and B is 0 comma 2. So given x plus y is equal to 2, so if you put x is equal to 0, y is equal to 2. And similarly, when you put y is equal to 0, x is equal to 2. So this is at this point, y is equal to 0 and x is 2. And here at this point, this is y-axis, along the y-axis where x is 0 and y is equal to 2. And this is given here in the tabular column. Therefore, point B is 0 comma 2 and point A is 2 comma 0. Therefore, a triangle area ACBA, that is ACBA equals, we have to first calculate the circle, the 1/4 of a circle in the quadrant 1, that is OACBO minus this triangle area OABO. This is the triangle you have to subtract. First you calculate the quadrant of a circle and then you subtract the triangle. You will get the required area. So therefore, we know that is given by z integral 0 to 2 y dx. So therefore, if you put over here in x square plus y square is equal to 4, you will get y is equal to 4 minus x square, or y is equal to square root of, this is the value of y is equal to 4 minus x square dx. This we have calculated and you can write simplify separately. In a rough sheet you can calculate, or here itself you can write x square plus y square equals 4 and you can calculate the value of y as y is equal to square root of 4 minus x square dx minus triangle. Triangle is 2 minus x, that is y is here in the triangle, y is equal to 2 minus x into dx, that is integral 0 to 2. See, this 2 minus x is obtained from the equation of a circle. Equation of a straight line. Equation of a straight line. Therefore, integrating using a standard form, here you get integral 0 to 2 square root of 4 minus x square dx is x by 2 into square root of 4 minus x square plus 4 by 2 into sine inverse of x by 2 limit 0 to 2. Okay, this is given. The standard formula is given in the text box on the right hand side bottom, minus this equation. Integral of 2 dx is 2x minus integral of x dx is x square by 2. That is using power rule. And limit is 0 to 2 as it is. Now we will substitute the values of upper limit and the lower limit. When we substitute, upper limit is 2 by 2, 2 gets cancelled, square root of 4 minus 4 square, that is 0. So 4 minus 2 square, 4 minus 4 is 0. So the upper limit is 0 plus 4 by 2 is 2, sine inverse of x by 2 is 2 by 2, sine inverse of 1 is pi by 2. So that becomes 2 into pi by 2 minus, this minus is 2 into 2, 4 minus 2 square is 4 divided by 2 is 2, 4 minus 2, and the value is simplified as pi minus 2 square units. That is the answer.